everyone, and you are welcome to the fourth session under Unit 3. So, in this session, we are going to look at the identification of organic compounds by IR spectroscopy. So, at the end of the section, you should be able to compare and contrast actual IR spectra of a variety of different organic compounds. Should be able to determine what key absorptions are characteristics of each functional group that can be attributed to that can be attributed reliably to other specific structural features. Should be able to use or learn about IR spectroscopy to determine what an unknown compound is. Okay, so before we start, we will look at what IR spectrum is. So infrared spectroscopy, right, measures the frequency of infrared light absorbed by a sample and the intensities of the absorption. So it measures the IR of the sample. The infrared light that is absorbed by your sample is being measured, right? So if it's being measured at say 2,000 per centimeter, then that is recorded. Then it goes ahead to tell us how intense that absorbed sample is. So depending on how intense the sample is, the peak that is shown will be either strong, moderate, or weak. So if you say strong, then it means the peak is very intense and very long. If it's moderate, something like this, and if it's very weak, then we have something like that. So that being said, we can look at the the position. So the infrared spectra has the wavelength range between 4,000 per centimeter and 6,000 per centimeter, right? And whatever is being absorbed is plotted as the percent transmittance versus wave number. So the percent transmittance is the x-axis, while the wave number is the y-axis is the percent transmittance, and then the x-axis is the wave number. Okay, so before we go on or throughout the process, you what you need to know is to learn the kind of functional groups that are being absorbed at specific wave numbers, right? So just as I mentioned, you have strong, medium, weak, and depending on the position of that spec. So if you have something around 300, what does it symbolize? What does it tell us, right? So when you have something around 1,600, 1,700, right, you can say that functional group is possibly a carbonyl functional group. Something around 3,000 tell us there's a CH bond. So your eye must be trained towards identifying certain characteristic group, right? And then so we will look at how to take IR spectrum. Now, before you take your IR spectrum, your sample could be probably a liquid or a solid. Now, depending on the kind of sample you have to that you want to run, it will tell us the kind of sample preparation technique that it has to go through to produce to be used in running your sample. So now, in order to determine the infrared spectrum of a compound, one must use a sample holder or a cell. So the sample holder or the cell is used to prepare your sample for analysis. Now, since glass and plastic absorb strongly throughout the infrared region of the spectrum, metal halides such as sodium chloride or potassium bromide are used. So our sample holder is made of sodium chloride or potassium bromide um, to to and so a single crystal of the sodium chloride or potassium bromide is cut and polished to give a salt plate that are transparent throughout the IR region and is used to fabricate cells that can hold liquid samples. So this is used the sodium chloride or potassium bromide crystals are used to prepare something that we call this the sample holder or the sample cell, or also known as salt plates. And these salt plates do not absorb in the IR spectrum. Therefore, when your sample is added, it actually measures this in the sample that is being added. So for liquid, you can add a few drops to the plate and then to one surface of the plate, and then you close it with the other surface, bring them together, causing the liquid to evenly spread out on right? So your sample can be run. Now, one thing you need to know is that the plate, the surface of the plate should not be touched. So make sure you only handle the plate by the edges. So if it's, your sample is a solid, then other preparation techniques are used. So the first one is to make a thin film of it. So a small amount of your sample is dissolved in dichloromethane and then applied on the plate and then closed together, right? Now, another technique is the Newell move technique, where the sample is going to fine powder and then mixed with a mineral oil, this known as the Newell, and then make a mold out or a suspension that is added to the plate and then run. And then the third one is to make a potassium pellet of it. So the sample is crushed in a mortar and pestle, and then the resulting mixture is prepared. Also, your sample is mixed with potassium bromide and then crushed in a mortar and pestle with the help of mortar and pestle, and then placed in the form of a pellet to be run by the the, the, the instrument, right? Okay, so let's look at the experiment. So in your experiment, in part one of your experiment, you were supposed to um, compare and contrast the actual IR spectra of variety of different compounds and determine what key absorption features or characteristics or functional groups can be attributed reliably to others specific features, right? Then the second thing is to run your own IR spectrum. So we'll take them one after the other. So this is a typical chart for common functional groups. So alkenes, the range, alcohols, alkenes, or double bonds, or triple bonds, or nitriles, or aromatic groups absorb in the region where they absorb, and the kind of intensity they give us, whether it's a weak or moderate, or medium or strong. So we have carbonyls, aldehydes, ketones, esters, acetic acids, all of them in the range they absorb, right? So in your part one, this is what you have to do. You have to learn to know the kind of functional groups and when the kind of in which regions they are absorbed. So there's also the classification of IR bands. So whenever there's a peak somewhere, and then you want to describe the spectrum, you use the keywords such as weak, medium, and strong in describing our IR bands. Okay, so this is a typical example of a spectrum. So a broad spectrum like this in the region around 3,500, between 3,500 and 3,000, and this broad spectrum indicates an OH group in your compound. Now, if the broad spectrum also comes with this shoulder, then you say this is possibly a CH bond. Now, if you have the same spectrum, you have a broad, a long peak like this, which in this case we call a strong peak, then this is possibly a carbonyl peak around 1,000, say 1,800, 1,700 thereabout, and this peak around here around 1,200, 1,300, and we can say this peak is possibly a CO group from an acid, so possibly a carboxylic acid, and also we have another one here that shows a CO bond, possibly from an alcohol. So this is the structure of the compound. So you see that the carbonyl functional group is here, the OH group is here. There's one CO, so this CO bond is here, and there's this same CO. So this Ca bond is possibly for this alcohol, and then this CO bond here is for this acetic acid functionality. Then we have the OH group here, the OH group there, the OH group here. You see how broad it is. So the OH groups are being absorbed here in this region, and then you can have our CH group somewhere here as well. So I mean, you need to know learn how to read certain functional groups in the IR spectrum. This is also a similar example. So for benzenes, for aromatics, you have a moderate or a weak peak mostly around this region, around the 2,000 there. There's also this peak that shows triple bond. There's also the CEC double triple bond as well. So you need to know the regions and the kind of functional groups that absorb in the certain regions. So there's a trial question here. So which of the following compounds IR spectrum is shown below? So if you read this IR spectrum, what kind of compound do you think this spectrum represents? So you can look at that. There's also another example. So you can also look at this. What spectrum is this? So these are the answers. So the first spectrum was for this compound 1, 2, 3, 4, 5, 6. So hexanone, 2 hexanone, and this is also for 1, 2, 3, 4, 5, 6, 7, 8 octane, right? So we are looking at the part 2 where you have your own sample that you want to run. So when you have your own sample, you can also run. So coordinate with one other, one other group. So your group should run two of the solids. So you are going to be presented with samples that you run their IR spectrum, and then based on the data, you identify the unknown. Okay, so this is a typical spectra of some compounds we are supposed to identify. So each IR spectrum belongs to one of the compounds shown. Write the letter of the spectrum below the compound to which it belongs. So you draw an X through the compounds whose spectra are not shown. So this is a typical exercise for you. It's also a typical exercise as well. So you should be able to identify the kind of compounds. So this straight away you can see there's possibly an OH group here. So you find the kind of functional groups and each region they belong to, and then you use it to identify the compounds listed.